Hello students, in the last video I discussed about solving this 2024 paper for ISC. Section A I discussed in that video. Here in this video I am discussing section B of the same question paper, that is 2024 paper ISC. Section B starts with question number 2, where it says write a chemical test to distinguish between ethanol and phenol. So how we can differentiate this? So the test that we can use is the ferric chloride solution. You can take out phenol. Phenol can react with the ferric chloride solution, dilute solution of ferric chloride, and it will give you a violet color, whereas ethanol does not give this test. So what will you write? Phenol gives violet coloration with dilute ferric chloride solution. Ferric chloride solution. Ethanol does not. So this is the test. Now the next thing we can write is, there can be other test also. So we can write about phenol reacting with bromine water. This is one test. Another test is phenol reacts with bromine water to give white PPT, white precipitate, white PPT, and ethanol does not give. Ethanol does not. White PPT of 2,4,6-tribromophenol is formed. You don't need to name those products, you can write the observation. So this is a test that can distinguish between ethanol and phenol. I have given two tests, any one of that is sufficient. Next question is, give a chemical reaction to convert acetaldehyde into secondary propyl alcohol. So acetaldehyde can be reacted. Acetaldehyde is CH3, C double bond O and H. This is acetaldehyde. We have to convert it into secondary propyl alcohol, that is isopropyl alcohol. We can react it with the Grignard's reagent, that is CH3 MgBr. Now the Br part here, it is partial charges are there, plus and partial negative charge on the metal and things. So we can find this is reacting. So the product will be, by the way, it has to be in dry ether. Dry ether is required, Grignard's reagent. The methyl group, it splits here, the methyl group joins the carbon. So CH3, C, the methyl group comes here. Here the double bond O becomes OMgBr. And the hydrogen is there. So this is an addition product. So this can be now hydrolyzed using acidified water acid hydrolysis. So which will give you the product, that is CH3, C, CH3, and here we have H, and here we have OH, plus MgOH Br. Okay, so we have converted it into secondary propyl alcohol, or it is otherwise called propane 2-ol, that is isopropyl alcohol. That is the question number 2 is now complete. We will go to the next one, that is question number 3. Question number 3 we have here. Give a reason for each of the following. The first one is, zinc, cadmium and mercury are considered as D block elements but not regarded as transition elements. Let's see the elements here. Zinc. Zinc has the configuration of 3D10 and 4s2. So the outermost orbit is complete. D is also complete. Cadmium, Cd, has the configuration of 4D10 and 5s2. This is the configuration. The next element we have here is mercury, Hg, has 5D10 6S2. So this is the configuration. Now what you can see here is they are not transition elements because the D block, the D subshell is completely filled. So they are transition elements because they come in that D block, but they are not, they do not have vacant d orbitals, or you can say they have completely filled d orbitals, completely filled d orbitals. So they are not having any transition. Electron transition is not possible. So transition elements need to have partially filled d. Okay, so then only transition is possible. That is why they are not considered as transition elements, even though they are in d block. Let's come to the second part. Transition metals possess a great tendency to form complex compound. So what is the reason? Transition elements have vacant d orbitals. They have, that is, transition elements have vacant d orbitals. Okay, since they have vacant d orbitals, they can accommodate what? Accommodate the lone pairs of electrons donated by the ligands. The ligands have lone pairs which link with the metal. There has to be vacant d orbitals for accommodating the electron. That is why they are able to form complexes. Number of complexes are possible depending on the availability of vacant d orbitals. Let's move to the next question. Question number 4. Convert the following by giving chemical equations for each. The first one is to convert ethyl bromide to diethyl ether. Ethyl bromide is C2H5Br. We can use Williamson synthesis where we have C2H5ONa, sodium ethoxide. Okay, so in this reaction what happens? The Na here and the bromine and the sodium, so they will be eliminated as NaBr. The rest of the molecules link C2 plus C2H5 O C2H5. Okay, so you got diethyl ether. This is diethyl ether. Okay, let's move to the next part. Phenol to salicylaldehyde. So how we can convert phenol to salicylaldehyde? We can take the Reimer-Tiemann reaction. What is the structure of phenol? Phenol is benzene ring with OH here. Phenol reacts with CHCl3, which is chloroform. We need alkali NaOH, and we need to heat also. So what you get here is the CHO group gets attached here. Okay, so this is how we write this reaction. Now there are other ways of writing this reaction also. So one of the ways is writing all the details of the products. We may use KOH also instead of this, so I can show you that also. Phenol is taken plus CHCl3, that is chloroform, plus KOH. In detail we can write and show the equation balance. 60 degrees Celsius actual temperature, and what you will have salicylaldehyde plus 3KCl plus 2H2O. So this is actually the fully balanced equation. So you may write either of that. Okay, let's move to the next question. Question number 5. Zirconium. They account for the following. The first is zirconium and hafnium are difficult to separate. So what is the reason for this? Because they have almost same chemical properties. That is the reason. So the reason for this similar properties due to lanthanide contraction, due to lanthanide contraction. Zirconium and hafnium have similar size, atomic size, you can say atomic size, and chemical properties. Okay, so if zirconium reacts, hafnium also reacts. So the reactions are same. So therefore difficult to separate. Therefore difficult. Atomic size is also same and reactions are also same. Okay, difficult to separate. Okay, so that is the reason for that. Second one is about the cupric salt and cuprous salt. Salts of cupric, Cu2 plus ion, are colored, while whereas salts of cuprous, Cu plus, are colorless. So this has to do with again the electron transition, d transition. So for this we can first we need to understand the electronic configuration. Now Cu2 plus, the configuration is 3d9 4s0. Okay, copper atomic number is 29, 2 electrons are lost, so 27. So we have 9 electrons here in the 3d and no electron in 4s. Now Cu plus has the configuration 3d10 and 4s0. Okay, so here we can find Cu2 plus, the d orbital is incomplete. So that means d-d transition possible. D-d transition possible. And here the d orbital is complete. So d-d transition, electronic transition from one d orbital to another, is not possible. Okay. Now this is one thing to note. At the same time, we have to mention this point also. Color of ion is due to d-d transition, that is transition of electrons among the d orbitals. So since this d-d transition is not possible, no color. Here it is possible, color is there. Color is there. Okay. So this is the answer for this. So the electronic configuration explains everything about this. Now let's go to the next question, that is question number 6. Question number 6 says, how will you bring the following conversion? Benzene to biphenyl. So how will you do the conversion? So you can write the reaction for this. So what we will do, benzene can react with the first maybe we can do it in 2 steps, so that you exactly understand what is happening there. Benzene reacting with chlorine in the presence of anhydrous aluminum chloride, AlCl3. So what is the reaction? The reaction is actually chlorination. The halogen carrier is used, so you get chlorobenzene. Okay, so you get chlorobenzene and HCl. So this is the first reaction. Now in the next step, what we do, we take chlorobenzene, second step. Okay, so second step I am making this way, chlorine this side, plus metallic sodium is taken and another molecule of chlorobenzene. So the chlorine is here, 2 atoms of sodium, and we need dry ether here, dry ether. Sodium is used here. So what will happen? The chlorine is removed by sodium, so 2NaCl is formed. Along with that, the benzene rings get linked, plus you can make the benzene ring, the next ring. Okay, so this is what is diphenyl or biphenyl. Okay, so let's go to the next conversion. Iodoform to acetylene. Iodoform. What is iodoform? Iodoform is CHI3. Okay, and we can convert it into acetylene. How we can do? Reaction with silver, metallic silver. 6 molecules, 6 atoms or molecules of silver will be required. So why 6 is required? So because we are having 3 iodines here and 3 iodines here, I am using 2 molecules, so these will be removed. So the silver will remove all the iodine and will give you, now we need to by the way heat also. So you have 6 AgI, the iodine is removed. So what will happen? The remaining carbon chain gets linked, plus HC triple bond CH. So this both this CH and this CH, they link together forming acetylene or ethyne. Okay, let's move to the next question. Question number 7. Okay, yeah, your space there. Yeah. Calculate the maximum possible electric work that can be obtained from a galvanic cell under standard conditions. How we can obtain this? So this is what we are going to calculate. Zinc and silver. The cell is given, cell representation is here. So they are asking you to calculate the maximum possible electrical work. So how we will do? First we will calculate the E0 for this cell. E0 for zinc cell is given, for silver is given. Combined cell, what will be the E0? So E0 cell is equal to, we will write E cathode minus anode. So it will be 0.76. 0.76 is given, minus 0.76 and plus 0.80. Okay, so that is equal to 1.56. When you add this, you get that, right? So we can move to the next step. Next step is to find out the electrical work. So for this we have the formula. What is the formula? W electrical or electrical work done is equal to minus N F E0 cell. Okay, N is equal to 2 here because in this reaction it is given 2 electrons are transferred, 2 plus and 2 of this will be transferred, right? So one zinc will give 2 electrons, so N is 2. So we can write the formula, that's equal to minus 2 into F is Faraday 96500 into the E0 cell that we calculated is 1.56. 1.56. That's equal to let's multiply in the calculator. So you are getting minus 301,080 joules. Okay, that's equal to minus 301.08 kilojoules. Okay, so that is the answer to this question. Next is question number 8. Give a reason for each of the following. Ethoxyethane does not react with sodium, but ethanol does. So we have to understand what is happening here. Ethoxyethane, what is ethoxyethane? Is C2H5O C2H5, that is dimethyl ether, that is ethoxyethane. And the other one they are talking about here is ethanol. Ethanol is C2H5OH. Now you can see this molecule C2H5, C2H are alkyl group and oxygen. Here alkyl group, oxygen with a hydrogen. In other words, we can say here they have the active hydrogen. In this molecule there is active hydrogen. Okay. Now this one does not have active hydrogen. So check the molecule carefully, both these molecules. So what is happening there? One of them have active hydrogen, the other one does not have active hydrogen. So because of the absence of active hydrogen, so it cannot liberate hydrogen. So no hydrogen evolved, and here hydrogen evolved when reacting with sodium. So sodium can replace this hydrogen. Here the hydrogen is, here it is not possible. So that is the reason for this. Next one, ethoxyethane with corn HI at 373 K gives ethanol and CH3I, that is methyl iodide, but not methanol and C2H5I. So what is the question actually? The question here is, why this, you see this molecule C2H5OH, ethoxyethane is C2H5O, C2H5, and it reacts with the HI. Okay, so the product is C2H5OH plus CH3I, but not CH3OH plus C2H5I. So the point here is the hydrogen and iodine, where do they go? The iodine goes with the, see, there is a reaction. The reaction is when it reacts with the HI. So C2H5I is not produced, CH3I is produced. So why this is happening? That is the question here. Okay, so let us understand what is happening. The conversion the carbocation. What is the carbocation formed here? The carbocation is stabilized by plus I effect. The carbocation produced here is stabilized by plus I effect, and also hyperconjugation is acting. Hyperconjugation, note these points, hyperconjugation. So because of this, what happens? The I minus produced will attack the methyl or methoxyethane. I minus attacks the methoxy group. Okay, so that is the reason. Okay, fine. Let's go to the next one. The option for this question has an option also. The option is an organic compound A having molecular formula C4H10O forms compound B with molecular formula C4H8O on oxidation, and then compound B gives a positive iodoform test. The reaction of compound B with CH3 MgBr followed by hydrolysis gives compound C with molecular formula C5H12O. Identify compounds A, B and C. Write the reaction for the conversion of compound A to B. So what are the compounds? Compound A, what is compound A? What is compound B? What is compound C? So we have to identify them. We also have to write the reaction. So let us take these compounds. Compound A, the formula is C4H10O. It is CH3, CH2, CH, CH3 and OH. So you can check the formula is matching with this, right? And in other words, it is butane 2-ol. Okay, now compound B. It is compound B because it undergoes oxidation, so it gives positive iodoform test. So with that we write this CH3, CH2, COH, CH3 and CH3. So this is 2-methyl butane 2-ol. Okay. Then compound C. What is compound C? Here it says reacts with CH3 MgBr, that is methyl magnesium bromide. So what will be the product that is coming when this reacts with this? So we have CH3, CH2, 2-methyl butanol. No, because this one says this. Yeah, from here it goes to compound B. Let me check again. Compound B will be CH3 CH2 C double bond O CH3. So that is butanone, that is B. So this it will be C. C will be the 2-methyl butane 2-ol. And then let us see what will be the reaction, how the reaction takes place. CH3 CH2 CHOH and CH3. This is compound A. On oxidation, so what is the oxidation? The oxidizing agent is K2Cr2O7, acidified potassium dichromate, and H2SO4 can be there, forms a compound B on oxidation. So what will be there? CH3 CH2 C double bond O and CH3 plus H2O. Okay, so and after this, yeah, so okay, it says only compound A to compound B. So this is done. So this is B and this is A. So that oxidation is done, right? Thank you. Now we will go to the next question. Question number 9. Question number 9, we have, if 200 cm cube of an aqueous solution of protein contains 1.26 gram of protein, the osmotic pressure of the solution at 300 K is found to be 2.57 into 10 to the power minus 3 atmosphere. Calculate the molecular mass of the protein. The value of R is given here. So we can use the formula. What is the formula? So osmotic pressure pi is equal to CRT, or we can say pi is equal to W upon mV into RT. So substituting the value pi, the value of pi, the osmotic pressure is 2.57 into 10 to the power minus 3 is equal to concentration, that is W upon 2 is 1.26 is the weight given here, 1.26 gram, divided by 0.2, 200 cm cube, that is 0.2 into molar mass, into R, that is 0.0821 into temperature, that is T, that is 300 K. So solving, we have to find M from here. So M is equal to 1.26 into 0.0821 into 300 divided by 2.57 into 10 to the power minus 3 into 0.2. So let's calculate. So we calculate 1.26 into 0.0821 to 300 . Yeah, so what you get is 60.377 grams per mole. So this is the molecular mass. Calculate the molecular mass. Value substituted straight. Going to question number 10. Benzaldehyde is less reactive than propanaldehyde. Why? So how do we answer this question? Question number 10. Okay. So let us understand benzaldehyde. What is the molecular structure? What is happening? So the plus I effect, which is otherwise called electron releasing effect, of the benzene ring, okay, brings a positive charge on carbonyl group. Okay, it decreases the positive charge of the ring decreases the positive charge on the carbonyl group. Okay, so therefore it becomes less prone to the attack by the nucleophiles. Therefore it becomes less prone to attack by nucleophiles. Okay, so that is the reason for this, right? Going to the next part of the question, that is preparation of ethanol by oxidation of ethanol. Ethanol should be immediately removed. What happens otherwise? So we know that ethanol gets oxidized to ethanol first. Okay, it gets oxidized. Now the oxidation does not stop here. So further oxidation is possible and final product will become ethanoic acid. So if not removed, what will happen? Ethanol changes to ethanoic acid, as the oxidation does not stop here. Okay, does not stop. So the product should be removed immediately, otherwise it will further get oxidized to the next product. Now the next question number 11. Why is Mn2 plus is ion more stable than Fe2 plus? So what is the answer to this? You can understand Mn2 plus and Fe2 plus. Let us understand the configuration. Mn2 plus, atomic number is 25, 2 plus means 2 electrons gone. So it has the configuration of 3d5 and 4s0. Okay, Fe2 plus has the configuration 3d6 and 4s0. Okay, these 4s electrons are lost, plus charge, 2 plus charge has come. 26, 25, 1 electron extra. So let us find here now Mn2 plus, this is half filled d orbitals. Okay, so because of that it is more stable. Now here this is not half filled, this has got unpaired as well as one pair, so this is not half filled, so the stability decreases, so less stable. Okay, so going to the next question, second part of this. Trivalent lanthanoid ions such as La3 plus, atomic number 57, and Lu3 plus, Z is equal to 71, do not show any color in their solution. Let's understand the configuration. La, lanthanium 3 plus, has the configuration, the atomic number is 57, so the configuration is 4F0, and this one Lu3 plus 71 has 4F14. So this is the configuration. So there is no unpaired electron, absence of unpaired electrons, no electronic transition possible, electronic transition possible, no color. Okay, so now F is complete, D also is complete, so there is no unpaired electron, so there is no color. So that's it in this video. I'll take up section C in the next video. Thank you.